Welcome back. Today we're going to work on section 6.3, solving trig equations when there's multiple angles. So like previously, find all solutions in the interval from 0 to 2 pi. And that right there means we're going to be working in radians. So what it means by multiple angles is, for example, number 1, sine of 2x is equal to a half. Now, if this just said sine of x, you would look at the sine function. On the y-axis, you draw a line across at 1/2, and there would be two solutions. And because this says sine of 2x, so let's graph sine of 2x, and then when does that equal a half? And I need to make sure that the window is set. This is going from 0 to 2 pi, and then I could actually adjust this, have it go from -1 to 1. So because of this 2x, it's going to draw the graph twice, which means that we're going to have twice as many solutions as usual. So instead of just 2 solutions, we've got 2 solutions and 2 more, so we've got 4 solutions. So this number right here is going to double the amount of solutions. If this right here happened to be a 7, then instead of 2 solutions, we would get 7 times that, we'd get 14 solutions. With a 2, that means we double this, we get 4 solutions. But we're still going to be using this graph. So I can use this graph to check my answer at the end, but to get the answers, I'm going to use this basic graph right here. So to begin with, take sine inverse of both sides. Sine inverse of 1/2. So take sine inverse of a half, and then divide that by pi, convert it to a fraction, and it's pi over 6. So we get that 2x equals pi over 6. Now it's tempting to divide by 2, but don't do that. Wait until the very end. Wait until we get all 4 answers, and then at the very end, we'll divide them all by 2. So looking at this graph, that means that this is pi over 6. There's a second solution right here, which is actually to the left of pi. So if you take pi and subtract pi over 6, this answer will be 5 pi over 6. So another solution is going to come from 2x equals 5 pi over 6. Now for 2 more solutions. So what you do is just extend this graph, draw it a second time. So right here, that's 2 pi. This would be 3 pi. And this would be 4 pi. So if you extend the line across, you'll see that we get 2 more solutions. So when I drew the graph the first time, it goes from 0 to 2 pi. When I drew it the next time, it goes from 2 pi to 4 pi. So in order to get from here over to here, then you need to add on 2 pi. So just take these original 2 answers, add on 2 pi to each one, and that's how we get the third and the fourth answer. So 2x equals, take a pi over 6 and add on 2 pi. So that is doing this, what this red arrow is doing. It's taking this solution, pi over 6, and then it's moving it over here to 2 pi plus a little bit, or in other words, 2 pi plus pi over 6. And then also, it's going to be 5 pi over 6 plus 2 pi. So then, once these are all done, then the last step is divide by 2. So the first one is going to be x equals, and then divide by 2 on each side. So then this will become pi over 12. And then divide by 2, and this one's going to become 5 pi over 12. And when you divide by 2 on this one, that means you need to divide this by 2 and you need to divide this by 2. So this will be pi over 12 plus a pi. And then this one, when you divide by 2, will be 5 pi over 12 plus a pi. Finally, this is 12 pi over 12, plus one more is 13 pi over 12. This is 12 pi over 12, plus 5 more is 17 pi over 12. And then I want to graph and make sure that I got it right. So there's the original sine of 2x and the 1/2, and then these should be the 4 answers. So I could check each and every one, or I could randomly pick one like the third one, and that should be this third answer right there. So then trace 13 pi divided by 12 should be right there. Yes. So now I feel confident in my answers. So now put them in a box and send it to Amazon. Amazon the country. No, sorry. Amazon the company, not Amazon the river. Next, how about example number 2, 4 cosine of 3 theta, ooh, getting fancy by putting theta, minus 1 equals 0. So first, add 1 to both sides. And then divide by 4. So this is saying, if you look at the cosine function from 0 to 2 pi, and you draw a line where y is equal to 1/4, then there would be 2 solutions. But that's if this just said theta instead of 3 theta. Because of the 3, we need to multiply the number of solutions by 2, so there's actually going to be 6 solutions. Now to get the very first one, you can just take cosine inverse of both sides. So cosine inverse of 1/4. Cosine inverse of 1/4. And then that, I'm pretty sure, is not pi over something. But to check, you go divide by pi, math changes to a fraction, and it does not give me a fraction. So this 0.42 is of no use. We're just going to have to use the decimal 1.318. So 3 theta equals 1.318. So that would correspond to this dot right here, 1.318. And then for this one, so for this one, it's to the left of 2 pi. So this one is going to be 2 pi minus 1.318. I sure wish I could calculate things like that in my head. 2 pi minus 1.318, 4.965. So 3 theta equals 4.965. At the very end, we'll divide by 3, but not now. Wait until the very end. So these are the first 2 solutions, and we're going to need a total of 6 solutions. So if you draw a cosine one more time, then this will give us 2 more solutions. And so by taking this and adding it on and making another copy, that means we just added on 2 pi. So to get from this answer to the next answer, then you add 2 pi. So essentially what I need to do is get the first 2 answers and then add 2 pi to each one. And then it's still 3 theta equals, and then just take each decimal and add on 2 pi. So then we have the first 2, then number 3 and number 4, and then continue the graph out and continue the red line over, and there are the next solutions. So we'd have the first 2, then number 3 and number 4, and then number 5 and number 6. So that means just add on another 2 pi. So if you take this one and you add on another 2 pi, it's going to be 1.318 now plus 4 pi. And then 4.965 plus 4 pi. And you might be saying, wait, our interval goes from 0 to 2 pi. This must be way too big. But remember, all of these still have to be divided by 3. By the time you divide by 3, these answers will shrink, and then all the answers are going to be between 0 and 2 pi. So then go to each one of these and divide by 3. Number 1, number 2, number 3, number 4, number 5, and number 6. So the first 2, I guess I should just use a calculator. 1.318, and now divide by 3. 4.965, and divide by 3. And then parentheses 1.318 plus 2 pi. Put that in parentheses and divide by 3. 2.534. And then 4.965, add 2 pi. Parentheses, divide by 3. 3.749. Now what I could do is just take this, copy it, and just change this to a 4 pi. So 4.628, and ultimately take this one, change that to a 4 pi, and 5.844. So 2 pi is 6.28, so this is still within the 0 to 2 pi. All right, last thing to do, check and make sure that I got it right. So 4 cosine of 3x minus 1, when does that equal 0? So for the window, this is going from 0 to 2 pi. And right now, y between -1 and 1, that's fine because I just need to see where it hits the x-axis. And there should be 6 times. 1, 2, 3, 4, 5, 6. So I'm going to randomly pick one. I'll check this one, 4.628. So that's going to be this one right here. Trace 4.628. 628. Yes, that one is correct. And I think I'll just check another one. Right before that should be 3.749. Yes, that looks right. So now I feel that those are correct, so put them in a box. And then one more. So I've been doing find all the solutions between 0 and 2 pi, because that's what we do in calculus most of the time. But it could be this one, find all of the solutions. And this one's example is going to be tangent of 2x is equal to 1. So the tangent graph looks like this. There's an asymptote at negative pi over 2, and there's an asymptote at positive pi over 2. And then when does tangent equal 1? So the tangent inverse, its job is it goes across, hits the tangent function, it goes down, and then tells you what value makes tangent equal to 1. So tangent inverse of 1, and then that is pi over something. Divide that by pi, change it to a fraction, and it's 1/4 of pi. So that means this is pi over 4. So then we would get 2x equals pi over 4. Then if you draw another branch of the tangent function, it will look like this. There's an asymptote right here at 3 pi over 2. Continue the line across, and there's another answer right here. So from negative pi over 2 to pi over 2, that's a length of pi. So in other words, the period of tangent is pi. So to get this next branch, you add on pi. So to get from here to there, add pi. So the next solution would be pi over 4, and then add pi. And then the next solution would be pi over 4, and add 2 pi's. And then add 3 pi's, 4 pi's, etc. Or, in general, 2x equals pi over 4 plus some number times pi. So instead of saying a 1 pi, a 2 pi, a 3 pi, a 4 pi, you can generalize that by just saying n is a number, and it could be positive or negative, because you could be going this way and have n equals a -1 or a -2 or a -3, or n equals a +1, a +2, a +3. So that's the general way to write it. The last thing we need to do is solve for x. So divide by 2, divide by 2, and divide by 2. So x is equal to, this will be pi over 8 plus n times pi over 2. And that is the way that you find all of the solutions in one tiny little expression right there.